Hi, and today we're going to be talking about simplifying, multiplying, and dividing radicals! Party on, dudes! We've worked with square roots, what times itself equals a number, and in this section we're going to start looking at higher roots like cube roots, fourth roots, fifth roots, 28th roots, 5,459th roots, that type of thing. So we're going to start with this. We are going to find each real number, and we're starting with the square root of negative 16. So if I wrote that out, it would just look like this, the square root of negative 16. And if you don't remember, the square root of a negative number is just plus or minus the normal square root, in this case 4i. But there's a slight issue here. You see this letter I? The problem is the letter I stands for something. And that's imaginary. Like our friend right over here, Bing Bong. But unfortunately, in the world of real square roots, imaginary doesn't exist. So there are, of course, no real roots. All right, let's try another. So here, this is the cube root of negative 1,000. Now you might remember earlier when we did the square root of a negative, it was imaginary. But at cube roots, it can be real. And that's because a negative times a negative times a negative goes back to being negative. So let's see, the cube root of negative 1,000. Well, let's see. I know that's 2 times 500, which is 2 times 250, that's 2 times 125. Oh, look, by the way, I have a trio right there. And I can cancel out these three numbers. Now, let's talk about 125. 125 is 5 and 25, which is 5 and 5. And, oh, what's that? We have a trio there as well. Well, now that we have two trios, we can actually say that both of those end up pulling out, which means we would have an answer of negative, because it was negative, and then 2 times 5 is 10. Let's try another. The fourth root of 16. Well, I know the square root of 16 is 4, and wait, 4 is a perfect square, which means I wonder if I tried 2 times 2 times 2 times 2. Hey, that's right, 2 would end up being our answer. All right, now let's try this one. If I did the real cube root of negative 8 over 27, that's a negative. Let's redo that. That would be the same as, let's see, negative cube root of 8 over cube root of 27. The cube root of 8 is 2. Cube root of 27 is 3. So negative 2/3. Okay, now we're going to simplify each radical expression. So first thing I would do is I would go the square root of 64, and I know that that is 8. Now, for these, we're going to be assuming that each one is, well, the absolute value of the square root. So in this case, 8, the square root of x squared is x to the fourth is x squared. But now the way that we got that, by the way, was we took that number and we divided by 2, which is what we're also doing with y, giving us y cubed. Let's try this one. The cube root of 27 is 3, and 6 divided by 3 gives us y squared. Here's another. 8 divided by 4 gets us x squared, and 12 divided by 4 gets us y cubed. All right, let's try this one. Oh, cube root of 64. Well, we know the square root of 64 is 8, but the cube root, hopefully at this point we've learned, is in this case 4, or negative 4, because it's negative 64. Now, a cubed 3 divided by 3 just leaves us with an A. And B, 15 divided by 3 is, well, 5. All right. So now we're going to simplify some expressions that don't perfectly, well, simplify. For instance, we can't make 30 better because 3, 2, and 5 are all the prime factors, and none of those will have a pair or simplify. So now that we don't know that, what we can do though, so the 30 is going to stay in the square root, but if we have 3 x's, 2 of those x's could be pulled out, giving us an x out here, leaving 1 x inside. So x square roots of 30x. Let's try this one. All right, so the cube root of 81, well, let's see. I know that that's 3 times 27. And actually, I know the cube root of 27 is going to be 3. But that leaves us with a 3 inside. Now let's talk about the next part. Y, there aren't 3 y's in that, but with z, there are 3 z's within 4. So I'm going to say z, and then I'm going to cube root. And we were left with a 3, the full y squared, and 1 z left over. Let's try this one. The 4th root of 32. So I know that that is 2 times 16. And 16, I actually know the 4th root of 16 is 2, because we've already established that earlier. Now, with s to the 7th, we can get out 1 7. So 1 set of 4 out of those 7. So I'm going to say just s. And with t to the 12th, we can actually get out 3. Inside our 4th root box, we're left with the 2 that we had that was left over. And we had 3 s's left. So I'm going to say s cubed. Now, when we're multiplying or dividing radical expressions, sorry, that just happens every time, the root must be the same. So don't multiply or divide square roots with cube roots. That's just, well, crazy talks. So we're going to multiply, if possible, and then simplify. So I'm going to start with this one. Now, you'll notice both of these are cube roots, which means we can multiply them. So I'm going to start with 25 times 5, and that is 125. Then I'm going to go, ooh, I need to underline that better. 25 times 5. And that is 125, as I just said. X times x to the 4th is going to be x to the 5th, because we just add those exponents together. Then y to the 8th times y cubed is going to be y to the 11th. Now that we know those, we can cube root them all. So we're going to start with the cube root of 125, which I actually already know is 5. Then we only actually have 1 set of 3 in x to the 5th because there are 2 left over. So I'm just going to say x. And then with y, we have 3 sets of 3 because we can get all the way to y to the 9th. But that leaves 2 left over. So inside our cube root, we're going to say x squared and y squared. Let's try this one. Oh, these do not have the same root value, which means we cannot multiply them. But you know, technically we can simplify. The cube root of 27 is 3, meaning we could have said 3 square roots of 3. Let's try this again, but where we can't simplify. So when we can't simplify, we just say, can not multiply. Okay, now let's try this one. So first thing I'm looking for is, are these the same root? And in fact, they are. Because we don't see anything, they are both square roots. So I can start to multiply. 3 times 2 is 6. 7 times 21 is 147. And I'm going to write the square root box in just a minute once I have everything together. X cubed times x cubed is x to the 6th. And then we just have y squared by itself. And now square root. So I need to talk about the square root of 147. Now, some of you might recognize that 147 is one of its factors is 49. That would be very few of you. So if you didn't recognize that, that's fine. But I did know that it was 7 times 21, which if I break it down is 7 times 3. There is a pair of 7s there, meaning I can pull that out. 6 times 7 is, in fact, 42. Now let's talk about x to the 6th power. If I'm looking for pairs, 6 has, well, 3 of them, because it's x times x 3 times. So x cubed. Then y squared, well, there's only one pair in y squared, so I'm going to say y. Square roots of, the only number left inside, is 3. Let's try that again in blue. 3. Now we're going to try dividing. Now, what we're basically doing here is, because I can't simplify either of those, I'm going to just put them both inside 1. So 6x over 3x, well, the x's simplify. 6 divided by 3 is 2. So the square root of 2. Can't simplify beyond that. Now let's try this one. 243 divided by 3 is going to be 81. And k to the 7th divided by k to the 3rd is k to the 4th. So, earlier in this very thing we discovered that 81 has 4 3s. We did that when we were doing the cube root, and we discovered it was basically 3 cube roots of 3. So when I break that down, the 4th root of 81 is in fact 3. And the 4th root of k to the 4th is just k. So it's like 3,000. Now, this time I'm not even going to actually rewrite it. I'm just going to say 108 divided by 4. That's 27. X to the 5th divided by x squared is x cubed. And y to the 14th divided by y to the 6th is y to the 8th. So cube root of 27 is 3. Cube root of x cubed is x. Cube root of y to the 8th is y squared times the cube root of y squared. And that's it. That's what we had to do today. That's what we're talking about. So, I hope that you all have a great break, because I know that this video is coming out at spring break. If you have any questions, of course, email me if you're one of my students. If you're not, then I do not know how you found this video, and I'm very sorry that you felt that you had to watch it. If you would please like, subscribe, all that stuff that people say at the end of YouTube videos. Watch my other stuff. It's super great. You're going to love it all. It's filled with math. Bye.